And we're live. Welcome to the 25th edition of the GraphQL Berlin Meetup. If you attended the previous meetup, you may have noticed that we actually had it at the Prisma office in Berlin. And this was actually the first time since the pandemic started that we were able to host the meetup in Berlin. But as the situation is very dynamic, we had to transition once again to a fully online meetup. So it's great to have all of you here joining today. In case you're in Northern Europe like I am, it's probably very cold, so be sure to get yourself a cup of tea or a cup of coffee, whatever you prefer. And if you're in a warm country, share a picture maybe and, make us a little bit jealous. So today we have some of the most prominent thinkers and voices in the GraphQL ecosystem, and we're very, very honored to have them here today. And before I get into our speakers for today, I also want to share that we will be running a raffle. So, to our speakers, Matteo Collina, who will be talking about GraphQL caching demystified. Matteo probably needs no introduction, but as we do per tradition, we will also give everyone here an introduction before their talk. We also have Jason Kuhrt. Some of you may know Jason, and he'll be giving a talk diving into the new Nexus Prisma plugin. And finally, we'll have Jamie Barton, who will be giving a talk titled Federating the Content Layer. And after that, we'll be doing the raffle. So for the raffle today, we are going to award a copy of this O'Reilly book, Building Micro Front-Ends, Scaling Teams and Projects, Empowering Developers, a great book by Luca Mezzalira. And you should already have the link in order to participate in the raffle. Yes, so this is the link. You can also just find it in the chat. And let's get into our first speaker for today. So our very first speaker today is Matteo. As I mentioned, he is the chief software architect at Nearform, where he consults some of the top brands in the world. In 2014, he defended his PhD thesis titled Application Platforms for the Internet of Things. Matteo is also a member of the Node.js Technical Steering Committee focusing on streams, diagnostics, and HTTP. Big shout out for the recent fetch release that I know that you were heavily involved in. He's also the author of the Fast Logger Pinot and the Fastify web framework, and he's given talks at over 60 conferences, including Node.js Interactive, Node.js Conf, Node Summit, JS Conf Asia, Web Rebels, and JS Day, to name a few. He's also the co-author of a book, Node.js Cookbook, 3rd edition, and in the summer he loves sailing the Sirocco, which I recently learned means the hot breeze coming from Africa towards Europe. So now, without any further delay, I bring you Matteo.
Hi, folks. Hi, everyone. How are you doing? Hey, this time around, Daniel, you are the host, and I am on the other side. You know, it was, it's we need to to do this a few times over the years. So, if for all of you, Daniel was part of the spoke at NodeConf last year, so it was that type of dynamic. Anyway. I'm so happy to be here presenting this talk about GraphQL caching. It's a very interesting topic. So which I really like, and I've been researching and implementing for the last while. So it's really, really keen for this talk.
I'm really excited. So the stage is yours, Matteo. And to our viewers, we're going to be doing a short Q&A following the talk, so be sure to drop your questions in the chat.
Please do, okay? Please ask me questions. This is a meetup, it's live. I like live talks, even though they are remote, but I like live talks. Otherwise, I can just record this and you will play, and I prefer not to. So let's do it in a second. Something that Daniel did not say is that I also have my newsletter at nodeland.dev, and you can follow my newsletter. You can learn a few things about Node and stuff, what's happening in Node community by it. So yeah, check it out. And of course, follow me on Twitter at Matteo Collina. You can see it in the overlay down here somewhere. There is an overlay. Hey, happy days. So first of all, this is a talk about magic. Okay, do you like magic? Well, I don't know. I was really fascinated by David Copperfield when I was a kid. Okay, and I don't know if you ever seen these fantastic show. This is in. I really wanted to attend one. Never attended one. Only watched on TV. So, but I find this quote that really resonate with me. So my job is to make people dream. Of course, there's a lot of technical stuff behind the scenes and a lot of hard work behind it. But I get to watch people see the result of that hard work and feel that wonder and feel that discovery all the time. This is more or less what I do. Okay, I tend to come up with some innovative way of implementing some code, and and people have that feeling of wonder and discovery that come from unveiling something new. So, what magic I'm going to use today? I'm going to show you how to improve the performance of your GraphQL gateway by 4 times, at least, minimum 4 times, probably more. Okay. First of all, let's talk about the tools that we're going to use to make this magic. So first of all, we're going to use Fastify. This is a framework for, it's a web framework for Node.js. You should be using it if you want to write fast APIs. If you want your code to be fast, use Fastify. Okay, it's also full-featured. It has a router, a logger, a lot of other things. I have a lot of talks on Fastify, so look them up. Okay, so you should be able to get a lot of stuff, information of it. We also have a nice website, so hey, check it out. I'm sorry if you hear my daughter screaming from the outside. I'm so sorry if it passed through, but that's like remote life. The other thing that we're going to use today, the other tool that we have, it's something I've built in a few years back and kept maintaining and improving. It's a library called Mercurius. What does Mercurius do? Well, Mercurius, it's a GraphQL adapter for Fastify. Okay. And I have been, exploring with it, maintaining it. It works really well. In fact, it's actually very fast, several times faster already compared to the most widespread solution that you can use. So it's great. On top of that, it has 2 modes. It has a normal operation, but also it has a just-in-time compiler. So you can actually enable the JIT compiler, so that it actually it takes your query, GraphQL query, and it compiles it down to JavaScript before executing it in a safe way. It's great, works beautifully, and we have it in production. It's really like that, really fast. We're also going to use AutoCannon. I don't know if you ever heard about this library, but it's a my load testing tool. I wrote it long ago, again on the sofa. On the sofa of my previous house. So happy days. Now, let's talk a little bit about what we are going to optimize and what we are going to make it fast. So first of all, we are going to use 2 services that have been federated. So we have a user service and a post service that have been federated together. We are going to turn on and off our cache. And our target services serve data from memory. So there's no database involved. In fact, if there is a database involved, you probably see way more dramatic improvements. So this is one of the example services. So we have our users, our schema, our resolvers, very easy. We are enabling the JIT, and it's pretty normal. Okay, pretty normal stuff. So it's time for magic. Let's see if we can make something disappear. So this is our baseline. Okay, I've run some benchmarks, and this is our baseline. You can test it at home, by the way. All the code in here, it's available online, so you can check it. It's in the Mercurius cache repository. So this is our baseline. So we run our test and we get our baseline. We have latency at the 99 percentile. That's how you measure latency. You take the 99 percentile of stuff, and then it's 80 milliseconds, and you can do 3,200 requests per second with a throughput of 1.5 megabyte per second. Good, bad, I don't know. It's what it is. Okay, it's our baseline. Okay, with Mercurius, if you're testing with other libraries that support Federation, you probably see lower numbers. So probably want to use Mercurius. We are at Nearform overall. One of my teams in the past developed a tool called Clinic, which can be used to create a lot of to create flame graphs and do performance analysis of Node.js. So this is a flame graph of our gateway. It's nice, right? You can see it as it's a gateway, and as a gateway does, it does a lot of HTTP requests. What is used to do HTTP request? Undici. What is Undici? Is the new library HTTP client that I have been developing as part of my activity in Node.js to implement the new HTTP client for Node. If you have followed the Node.js development, we are releasing Fetch soon, which will be using this stack. Now, Undici uses some WASM internally, and also it has some other stuff in it. So you can see it on the left of this slide of this. Okay, that is a big block of things that come from Undici. That is our HTTP client, right? So and this it's a gateway, right? So if it's a gateway, it's doing a lot of HTTP requests. That's what a gateway does. So it's normal that you're spending a lot of CPU time doing HTTP requests. So how much can we improve this? Like how can we improve? And the result, it's quite a lot. Just by enabling the caching with no TTL, no time, no spent, we can put it in 4, divided by 4. Okay, we are improving it 4x. We are improving it and bringing it to we are moving 4x the number of requests and 1/4 of the with a 1/4 of the latency. It's impressive. More or less, it's 4x of the amount of even on the throughput. Now, we can even increase the TTL, so the time that the data stays in the cache. Whoa, wait a second. You're saying that you made your HTTP server go 4x. Yes, that's exactly what I am saying. And this is the flame graph to prove it. So after we've done all of those things, this is the flame graph. So you can see that the flame graph is totally different compared from the previous one. All those calls with Undici have been removed. It's not doing an HTTP request anymore, but it was a gateway, right? So, however, something new has appeared. Now the bottleneck is the caching layer, and there is this little library called async cache dedupe that I don't know. Maybe we are going to explain how we did some magic now. Okay, so let's talk a little bit of where did the HTTP call go. Okay, first of all, we are going to remove the clones. Okay, we don't want the clones to win, so we need to remove the clones. So we deduplicate. Let's talk a little bit about deduplication. Okay, now you have your event loop. With this event loop, which you are probably familiar with this kind of visualization, right? You have one event, you have processing some JavaScript, then you schedule some IO to happen, then some events come through and you execute one of those events, right? It also means that if you want to make your code fast, you need to, wait a second. If you want to make your code fast, you need to minimize the time in which you execute your JavaScript code. Now, let's imagine that we are receiving a GraphQL query. It's a new event that comes through. It goes into the Node.js C++ layer, and at some point it executes our JavaScript, which then in turn will call our resolvers and do all those things. Okay. Now, and in the end, it will also process all our promises too. Now, what we can do, though, is inside our JavaScript function, when you are invoking our resolver, we could create a deduplication cache. So we can compute for each resolver that we are invocating, we can compute a key and retain the promise that that resolver is returning us. So basically, what we can do is have this key and then have a pending promise waiting for it to happen. However, whenever something else comes through that has the same key, essentially, we can take it from the dedupe cache. Now, it will, these exist up until the promise is pending or up until I keep the result. So, and this is what async cache dedupe does. It's a really powerful module that, to be honest, you should all be using today if you're working with Node, but it's a little dark secret, okay, of like dark magic type of stuff. So I don't know if you want to play with magic, but if you want to play with magic, this can really improve the performance of your systems. And you create your cache, define some of your methods, and then pass in arguments, and you automatically have deduplication, so and caching all in one box. So what does deduplication means? It means that if I am invocating the same function with the same arguments in a given amount of time, in a given time slot, in fact, you will be keep resolving to you will not invoke that function only once. What does this mean in practice? If we are reading data from one database, what we are doing is that if two users are resolving the same the data to the same database, we are not issuing twice the queries. We are only issuing the query once and get the data to both users. It's great because it can reduce the strain of our database for most of the very popular content. And most of the application web apps right these days are very skewed towards certain data versus others. So it's great. But we are talking about this. How can we compute a good cache key, right? What does a good cache key comes from? Well, we have. Let's talk a little bit about a resolver. A resolver includes root, that is the current object, args, which are the arguments of that resolver, then the context, which is the Node.js request, response, the database, the HTTP authentication of the stuff, and the info, which includes the actual query being computed. So a good argument for a good way to compute a key is to use a stable stringification algorithm. What does it mean? Well, with JSON stringify, if you swap two keys in the object definition, you will get two different objects, two different strings. With a stable stringification algorithm, you will actually get the same keys, even if the object is defined. And we have used this. It works great. However, now this library, it's actually the bottleneck of my code. So if you know a better algorithm to generate a key, an hash key from an object, just let me know. And specific for GraphQL, though, we also need to add some more stuff on it. So we need to add the current self object. We need to add the arguments that the resolver is being passed through. But we also want to specify something called the field nodes. The fields, which are the fields being selected, because if you are selecting the multiple different fields, we want to limit it, and so on. So in fact, when we call it the 0-second TTL, is just with deduplication. So just making sure that we only call the server once per for each time interval. It just reduces greatly the reduces the latency and improve the throughput. It's great, and it's again, if you increase TTL, you are getting some more improvement, but not so much. The reason of this difference is because the target server is actually very fast. It serves data from memory. If it was going to do a very complex database query, you would have seen a way bigger difference. Well, coming to the end, but I still have a little bit more to talk about. All of this was doing caching in process, but in process caches are problematic. they can get out of syncs between multiple processes, suffer memory leaks, and so on. So the actual good answer here is use Redis. It's always a good answer. Use Redis, right? But the math does not add up, because if we need to store data in Redis, if you have 100 GraphQL, if you have 100 query per second, GraphQL query per second, that each of them invoke 20 resolvers, we will need to do more or less 2,000 Redis get per second. However, Redis is, we need to have at 0.5 milliseconds round trip to the database, including network. So that does not add up. It doesn't seem a good solution, right? How can we fix this? Because it's not working as we thought it would. Well, that's not true. I have a solution. So essentially, I have invented this technique called auto pipelining. I spoke about it at RedisConf 2021. You can watch the talk. So it's there to watch for you. The idea is that it batches multiple commands in one single Redis pipelines. So basically, it batches all the commands so to limit the round trip time. And this is great, because in that way we can just pay the round trip time once and perform thousands of commands, And the result is, the exact same technique, and that we talked about before. It's the exact same caching, deduplication. It's the exact same event loop technique that we were talking about before. So some real life statistics. We have deployed this into one in production. We have received 100 more requests per second in practice, and we have a 5x expansion factor in Redis. What I mean is, for every single GraphQL query, we are doing 15 get command on Redis. So, whoa, the Redis is not Flixi and I. Well, I'm coming to my talk. As I said, this talk was a bit of a rush. So I just want to finish with a few considerations. As you probably know, there are two hard things in computer science. One is naming things, and the other one is caching validations. So this is caching. So how do we do caching validations? Well, how can we implement it? And it's supported. It works. It's done. So we just need to implement it. So how do we implement it? Well, what you do is that you need to specify a caching policy, and you need to tell for each one of your resolvers how do you want to do caching, how you want to do invalidation. So first of all, you have a concept of a reference. So whenever you are a resolver is being called, you want to create some references, and what you do with those references, those keys, those are strings, and those strings you will use then later to invalidate those cache. So basically, it's an inverted index for cache entries. Essentially, you specify these references functions, as you said. So the top post is just return a key, top posts. And then we have a get post policy that will specify a reference for get post arg.pid. And then when a mutation happens, you can actually tell the caching layer to invalidate both the get post arg.pid and the post tag. It works beautifully. Okay, so we've done a lot of research to kind of 6 months to nail this. So it's probably worth a full talk on its own, but it's that will take 1 hour to explain how all of this works. There's quite a few complex data structures in it. It also supports Redis, so you can have it on memory or on top of Redis. It works very well. However, we also have a companion script of a Redis garbage collector to run, so that there's no memory leaks, but the usage of Redis, some of those data structure will take some time to clean up over time. So you might want to run this garbage collector script to clean to reduce the size of your dailies from time to time to optimize its performance. This being said, thank you for having me. It's been a blast, and please follow me at Matteo Collina on Twitter. And in case you wonder, I work for this company called Nearform. We are hiring all across Europe, Europe, North America, and South America. So kind of everywhere at this point. If you are look to develop stuff with GraphQL, Node.js, React, or you are into DevOps even, or more or less every possible role that you can imagine in tech, please reach out. We have a lot of positions open. So check us out. And yeah, thank you for having me.
Thank you so much, Matteo. That was really insightful. And if you're okay, we'll get into a couple of questions.
Sure thing. Here I am.
So in the example that you gave, really, you sort of differentiated between using an in-memory cache inside the Node.js process, and then you also sort of went a bit into what it would be like and some of the trade-offs when you're using something like Redis, which would be an external cache, but it would be consistent, say, if you have multiple instances of your Node.js runtime. I'm curious to hear, how do you think, because the example that you gave was for a federated GraphQL gateway, which essentially just proxies a lot of the GraphQL requests. How do you approach caching when it comes to working with a database like a relational database or even MongoDB? Because you suddenly have a concern also about some of the pressure on your database, and you might be sort of wondering, is this something that I should solve by adding caching to my GraphQL layer, or is this something that I need to solve on the database layer? So I hope that sort of...
Yes, makes total sense. In fact, we have deployed this in exact same scenario in front of a MySQL database and a MongoDB database. And the result has been, especially against the MySQL, on top of the MySQL one, has been phenomenal. Because that database is extremely in terms of data, and in terms of some of the queries were actually really complex. So the result was, basically suddenly somebody was starting to complain because they were wondering if things were working because the auto scaling was not kicking in on the cloud. So it was us literally. It was the auto scaling was not kicking in, and they were like, why is this happening? Like the database used to scream a lot. They were to over provision significantly. Now the database is mostly idle. It's a completely different new world. Okay, especially if you can cache if you have if we have a subset of queries that is accessed it's accessed very often, versus very few queries that are also versus a long tail of queries that are executed less often. So it really depends on your use case pattern. But in my experience, it's you can absolutely use the exact same logic, exact same code, and it will just work exactly the same with the same performance benefits.
Got it. And would your general recommendation to choose either in-memory or Redis, or are they ever combined?
No, I would just in my experience, so the memory one, it's great. However, it can suffer from
inconsistencies across processes.
Yes, exactly. While the Redis one is consistent. So usually you would want to use Redis. That's the TLDR. However, if you can accept a little bit of inconsistencies, especially with very low TTLs, the in-process one is actually great. So if you're putting a TTL of 0 seconds or 1 second or 2 seconds, you can actually use the in-process one and save some money. So you have one less piece of software to maintain. So you can just use the local one, and you're good.
I see. So it's really like dependent on the nature of the business sort of logic that you're implementing and how important the consistency. If you're okay with essentially eventual consistency, I guess would be the term here.
Yeah.
Then
Exactly.
I see. Thank you so much. We also had a question from Sake Codes who asked, does Fastify Mercurius replace Apollo Server? Yes, it does. Any comments on sort of some of the differences between them besides performance?
Oh, yes, there is one thing. It has built-in data loaders. So if you have been implementing GraphQL and you don't know what data loader is, what a data loader is, you should really check it out. Okay, it's I would say it's almost it's really problematic if you have a GraphQL server and you're not implementing data loaders. Data loaders.
Which one has it built in?
Mercurius.
Okay.
And it's that is one. It also has a few other features in it, so you can have the depth protection, so the max depth protection limit. So you can even say, well, I only want to have, I don't know, 4, 5, 6 queries that have that have depths of 4, 5, or 6 levels. If you combine this with the data loader patterns, it means that you can put an upper bound to the maximum effort that you can do while doing to the maximum amount of database queries that you can do when resolving a GraphQL query, in the sense of you have a maximum D depth, so depth, okay, query. So if you have depth 5, you can assure, if you're using data loaders and you can only have and a max depth of 5, you can guarantee that its system guarantees that you're only doing at most 5 queries to the database, and not end up in that n+1 problems that is usually plague most of the GraphQL implementation that I've seen.
Got it. Thank you. And I think you gave a great talk last year, it was, I believe, on GraphQL, and you covered really the n+1 problem. So I'll try to find a link.
Yeah, there is one lurking somewhere on that one. I have a few slides I have a few presentation of that. It's great though, but it's very important. So
Matteo, thank you. It's been a pleasure having you here. Is there anything you want to share before you leave? I'm already dropping the link to your newsletter. That's Adventures in Nodeland. So you can, you've probably, our viewers, you've probably seen all of the open source libraries. And in this newsletter, Matteo really dives in and shares on a weekly basis, I believe. You do this, you share your adventures and your perspective on how all of these projects are progressing.
Yep, that's exactly it.
Thank you, Matteo.
Oh, one more thing. Nearform is hiring, okay? Just to be clear, if anybody just to, in case anybody wonders, we are hiring. So, hey.
So if you want to work with Matteo, this is your chance.
Yay. Bye-bye.
All right. Ciao. Okay. We'll try to get the slides, Diego. Thanks for bringing that up. And... we are now going to move on to our next speaker. And our next speaker is Jason. And some of you may know Jason. He's been on the Prisma team for quite a while. So Jason is a software engineer with a passion for developer experience, system design, and tooling. He's educated in design theory, practice and ethics. And he became fascinated by the systems aspects of software and the community of open source. Over the years, his journey progressed from the front end to the back end, where he has delved into API services, DevOps, architecture, and more. He made creative and leadership contributions in many environments, mostly at startups, and today he leads the developer productivity team at Prisma, responsible for the control plane product of the Prisma data platform. And I think probably most relevant for today, Jason is also the co-creator of Nexus, and this is going to be his topic for today. So Jason, welcome.
Hey, thanks for having me. Can you hear me all right?
Yeah, we can hear you great. You are joining us from Montreal, Canada, if I'm correct, right?
Yeah, that's right. It's minus 12 today, which means it's warm.
Ooh, okay. Well, I told our viewers in the beginning, get a cup of tea. I've got one, and I'm really ready for your talk. So I won't take any more time from your talk. Just to our listeners and viewers at home, be sure to drop your questions in the chat, and we'll get to them after the talk. Jason, are you ready to share your screen?
I am. I'll give it a shot here. Slides, video file, share screen.
And also a quick reminder, if you've joined recently the live stream, we also have a raffle going on, which you can join at the link in the chat.
All right, I believe I'm sharing now.
All right, we're going to get this 80s mirror effect.
Yeah, there we go.
Infinity.
Cool.
All right, the stage is yours.
Awesome. So today I'm just going to give a quick talk on Nexus Prisma. It's also going to be a little bit internals. So we'll go with kind of what it is for those that don't know, and a little bit of a demo, but really we'll spend most of the time, or at least some of the time, just on how this is implemented, and kind of give you a sense for what a Prisma generator looks like under the hood. Nexus Prisma is a pretty simple tool. It's pretty accessible. So I think if you've been curious in writing a Prisma generator, but haven't tried yet, Nexus Prisma is not necessarily, it's like potentially a good place for you to just to browse around in the code base and so on. So anyway, we'll dive into that. So what is Nexus Prisma? So the problem space is that it's trying to solve is if you're building a backend that has a database and a GraphQL API, and you are using Nexus for the API layer. So Nexus is a way to build GraphQL API schemas. And if you're using Prisma for the database layer, and Prisma is an ORM for accessing data in a database. So if you've got these two pieces, well, Nexus Prisma, as the name suggests, is a way to sort of integrate these. And what you want in this case is you want some of your API layer to reflect your database layer. And so what that means is you might have schemas and models in Prisma in your database, and you need something that is pretty similar in your API. And you don't necessarily want to rewrite or duplicate all of that. So some kind of linking that you want to express. So the solution in the form of Nexus Prisma is a Prisma generator. And what it does is it outputs a library of pre-configured Nexus object types and object type field configurations. So this makes it pretty easy to quickly plug into your API layer aspects of your database schema. And you can kind of pick and choose and extend or modify. So it's fairly flexible, as you'll see in a little bit. Just as a sneak peek, sort of really high level, what this looks like is you've got a Prisma schema, something probably more complex than this, but say here with like a model user. And you'll have some fields and so on. And these treble slashes, these are, so you can make comments in a Prisma schema with double slash. Triple slash just turns that comment into something that shows up in the AST of the schema file. So generators can pick up on these triple slashes and output it as documentation, say JSDoc or GraphQL descriptions and so on and so forth. So you've got your Prisma schema, and then you run Prisma generate, and what you get out of it is this Nexus Prisma library. So this would be in your application code now, and you import from Nexus Prisma something such as user. And this is directly, like the fact that you can import user is because you defined user over here in your Prisma schema. You use Nexus, you sort of do the typical object type, and you start constructing something that's in your API schema. But now you can take the user that you've imported from Nexus Prisma, and you can start to piece together sort of things that were taken from your Prisma schema and put that into your API schema. So some simple things like the model name and description, but then some more useful things like you could just get a field automatically put into your API there. And this will work with like relations and so on as well. And so we'll do a demo quickly of an actual running application showing more or less this. And then we'll dive into the internals. And the internals, we're going to cover some of the things we see in this diagram here. So at a high level, to run through the sort of the diagram, imagine you are here and you are running as a developer, working on your application, Prisma generate in your terminal. And what sort of starts to happen from there is first the Prisma schema is going to be read from your application, and that's something that just the general Prisma generate CLI is taking care of. And then it will run through the generators that are defined in your Prisma schema. So Nexus Prisma will be in your will be defined as a block in your Prisma schema, and that's sort of when the sort of Nexus Prisma generator starts to, all of its stuff starts to run. So it has a little CLI. Generators all have sort of a callable binary CLI, and that gets executed. And from there, the generator sort of takes over of all the logic that needs to take place for whatever it is trying to do. So in the case of Nexus Prisma, what that means is, first of all, looking to see if you have a Nexus Prisma kind of configuration for things that you can basically configure Nexus Prisma generator itself, and there's a special file that it will look for if you optionally if you want to do that. Then it will write some generated runtime, which includes some JavaScript and some TypeScript types. And then from that point, you're ready to go. Your application code, wherever that's sitting, will import from Nexus Prisma. And at that point, the generated runtime will also import from some static runtime. So Nexus Prisma is not just a Prisma generator, but it also ships with some sort of just static runtime that is not needed to be dynamically generated. And we actually try to architect the generator to have as little dynamic generated code as possible, just as an implementation strategy. So that's actually, the TypeScript types are really helpful for that, because we can kind of keep the runtime fairly dynamic while making it look very static, because of the TypeScript types allow us to kind of tailor what the API appears to be when you're consuming statically. And then, so then the generated runtime imports whatever it needs from the static runtime, and you're off to the races. Your application is running. So we'll kind of go through some of these blocks in a little bit. All right. So I showed you a little code snippet before of an application source code, but we'll kind of go through now a live one. So what I have on the screen here is a very sort of simple toy app that's just a small server, GraphQL server, with a little bit of a schema here. And there's a Prisma schema. We'll start there. So this is the Nexus Prisma generator block that I was talking about that you would have alongside your typically your Prisma client generator block. Where in this case, I have a local Postgres that I'm connecting to, and that's just, yeah. Normally, you probably have an environment variable there, but this is just sort of a quick and dirty demo. Then we have two models in this Prisma schema, just a user with an ID that has multiple posts, which have a title, and that's it. So really, really, really simple. If we jump to the source for this, you'll see that I have Nexus Prisma here, and I'm importing user and post. If I go and peek in what's in there, there's nothing else except for settings, and that's some sort of runtime settings. So I can configure certain aspects of Nexus Prisma on the runtime side, as well as on the generation time, which we talked about, like a configuration file. So when I'm using user or post, you can see here, basically everything I export outside of this, everything I'm exporting from this module will show up in my GraphQL API. So I'm creating a user object, a post object, a query to sort of send in read operations into my API, and also mutation to send in some, to change things, to create a user in this case. So when I'm creating a user object, normally you might do something like, okay, I want to have a user, it's going to have posts, and then I'm going to say, okay, the type here, and then you have post object, and you might say, okay, this is actually going to be a list, and then I'll make a resolve, and here I will get the context, and with the context, I'm going to then access the Prisma and get the user and find many, right? And so you might write something like this, probably in practice with a lot more going on, like authorization or whatnot. but generally speaking, you might kind of have various fields on your models that are being implemented. With Nexus Prisma, you kind of just get that for free. So with the user, you get generated based on your Prisma schema, the description that you put, if you put any. You can see here it's statically typed as undefined because I have not put a description on top of my model. You get the name, you get ID, you get posts. And these are fields, actually. So the $sign here is just a prefix convention to avoid namespace collisions, because you might have a field on your model called name, or you might have a field on your model called description, but you can't actually put $signs in prefix position of Prisma model fields. So this guarantees that we'll never have a collision with user space field names. And so these fields here are then in turn just GraphQL object type field configuration. So here I've got for an ID field, it's description. Again, it's undefined because I didn't put that in my Prisma schema. I've got the name, resolve, and type. And so resolve tends to be the more interesting one, at least from sort of, like a lot of this is just pretty static. Like name will be a string, type will be a string, description will be a string. But this resolve is actually a function, and that sort of gets auto-implemented for you. Now, for scalars, usually default resolvers are sufficient in a GraphQL API, so there's not too much you need to do for scalars. But having resolvers are pretty handy for relationships. So, for example, in the user, what we had before, user posts, the resolve function for posts would actually involve using the Prisma client to query the database to go get all of that user's posts. And so you don't have to really think about that when using Nexus Prisma, which can be a really, this can be good for prototyping. In some, we at Prisma on the Prisma data platform, we have a GraphQL API, and there are some relations that are just simple, and we're able to rely on the defaults that Nexus Prisma provides. So, but you can pick and choose, and you can also override. So for instance, if in this field, I want to use what we get from Nexus Prisma, but I do need to have a custom resolve, that's pretty trivial to do. I just would put the resolve method below the spread, and now I get everything this Nexus Prisma gives me, but I'll be able to customize resolve. And if I want to sort of wrap the resolver, that's also trivial. I would just access the post resolve, and then here, args. Put that in, args. And now I can do some stuff after. I can do some stuff, I can do some stuff before, I can do some stuff after. I can capture the result, return the result. And I'm still completely leveraging what Nexus Prisma gave me, but also doing whatever extra logic I need. So there's a lot of flexibility here. One of the design principles of Nexus Prisma, the new one, because there was an older version in the past, is to sort of give you more static primitives that then you can put into higher levels of abstraction in your own code. Okay, just to make this run, I'll show you a couple little tweaks here. So we talked about the triple comment, so let's give that a shot. So in here, post, I'm going to say this is the post, period, save that. This is also going to give you a sense for the workflow. So here I've changed the Prisma schema. So what I need to do now is rerun the Prisma generators. So let's run yarn Prisma generate. And then I will restart my server. I guess I could have done that in a separate terminal, but whatever. And now if I come back to, that was on the post. So if I come back to the post and say I want to take advantage of that description I did, you see also the static type is now a string. Whereas if you compare with name, let's see there. This description there is still undefined because we haven't put a comment on that. So just takes an extra Prisma generate to once you change your schema, just Prisma generate and you get that back. Okay. At this point, what I think we can transition to then is, now you have a sense of this, it's pretty easy to just try it out for yourself and kind of go. There's a website, nexus.prisma.io, and you can kind of explore some of the other features that it has. Like there's custom scalars provided for you. So in Prisma, for example, you can say, say there's a data field, and you could turn this into a JSON. This is made conveniently available for you as a custom scalar in GraphQL from import from Nexus Prisma scalars. And so here we have the JSON. Also gives you some sort of JS doc on what that particular custom scalar kind of is about. And then you've got other ones. So all these custom scalars that Nexus Prisma ships with are the ones that you might find in a standard Prisma schema. So if you are using those, you're good to go already with Nexus Prisma. Saves you a little bit of time. All right. So how is Nexus Prisma implemented? So first thing, if you are curious to go look at the source code at one point, that's at Prisma, Nexus Prisma. Is the repository on the Prisma org. And this is the demo still, is that right? Nexus Prisma. All right. So this is the code base. It's pretty small. And what we're going to try to do is go through sort of how the diagram was in regards to these different steps. So first we said was that CLI part. Then we write some dynamic.
Any chance we can make the font a bit bigger, Jason? Sorry to cut you off.
No problem. Yeah. Is that better? I think that's like hopefully a good compromise, because any bigger and I'll have a hard time seeing the files. But I think that hopefully works. Yeah, so we'll go through the CLI, and then we'll look at how the TypeScript types and how the JavaScript is generated, what that sort of static runtime is about, and also sort of these parts about the settings that we talked about, this configuration at generate time, and there's also configuration at runtime. All right, so there is a Prisma NPM package called Generator Helper. And so this is sort of like a foundation that you can already use to build a Prisma generator and handle some of the lower level plumbing. We in the Nexus Prisma codebase, we've got this SRC, everything is in there, CLI, and then we have this Nexus Prisma, and so that's exposed as a bin here, so Nexus Prisma. And it's important that the name here matches what you expect. So this here, Nexus Prisma, is going to be, it's a bin that needs to match what you call in the generator block over here. You see that we have Nexus Prisma, provider Nexus Prisma. So the name of the provider, there has to be, it's going to try to execute something called Nexus Prisma on the path. So this name is basically determines what the provider name is going to be in the user's Prisma schema file. So this CLI, we just start with the generator handler. We have an on manifest that has some boilerplate around kind of what, like for instance, the pretty name. So when Prisma needs to print something in the terminal about this generator, it will use the pretty name. Default output is where should the generator output files to. So there's this concept of the default output. Most of the meat happens on this onGenerate callback. So from the side of Prisma, what we get back, what the generator gets back is what's called the DMMF. The DMMF is basically an AST representation. It's more than an AST it's partly an AST representation of a Prisma schema, but it also includes what are the operations that are possible on all the models that are in that AST. So user and post and all these different models, and enums, they will support operations like find many, find unique, and these kinds of things. And they'll have fields, and find unique will be influenced, like what you can pass to find unique will be influenced by what are the unique fields in a model, and so on and so forth. So DMMF kind of has a rich set of both AST, but also kind of the CRUD that's possible for your schema. So it can be actually quite a big data structure if you have a big Prisma schema. There's some information about other generators. So for example, we use that with Nexus Prisma to find the Prisma client generator. If we don't find it, we kind of know that you're in an error state, right? You can't use Nexus Prisma without having the Prisma client. So that's one use case for having access to other generators. You get access to the generator that is this generator. So what that means is the generator block for Nexus Prisma in your Prisma schema. This generator is going to get access to maybe how you configured that with a custom output or something like that. And finally, the schema path. So where is the user's Prisma schema on disk? The generator gets access to that. So with these pieces of information, and I believe there's some other things lurking in there. There's some other things, but I don't know details about all those. This is sort of probably the common set that you'll be using. The first thing we check for after validating that you've got your other needed generator is the custom output. So if you're you can output Prisma client to a specific location, you can also output Nexus Prisma to a specific location. That's not sort of the default. The default is to go into node modules, and you don't really see or think about it as a developer, but that can be controlled. We access the GenTime settings, and depending on where you've customized, if you've customized the output location of your Prisma client, we need to know that because Nexus Prisma needs to import it. So we sort of do some under the hood checks there about that. We load the GenTime settings that you may or may not have for Nexus Prisma itself. So this here goes and fetches the file. And in your and it also runs the settings. This is a settings module, so it's an actual TypeScript file, so it's code. And when that code is executed, it has side effects. If you've correctly used the GenTime settings, it will, because it's been run, it's run by this function, whatever you've the module that you've created. So what that means is the settings GenTime here will be the same setting. It's like a singleton, and that singleton will have been used in your configuration file. And so we rely on that mutation to just transparently get access to anything that you've configured. So for example, we'll find out if you've customized the output directory and if it's absolute or not, and make sure that everything is working well there. Then finally, we get access to what's called the Prisma client DMMF, slightly different than the generic DMMF. Prisma client basically has some processing that it does on top of it, very light, but it's still important for Nexus Prisma to know about that version of the DMMF. So we just do that transformation just like Prisma client does, so that we're working with sort of apples to apples. And then we kind of get to the end, basically, of the CLI, and it's just generate, runtime, and emit. So that's sort of the CLI. Once you get to the generate part, this command here, it basically is going to, right, like we said, there's TypeScript types and there's JavaScript runtime. So there's what's called the module generators, which is a separate part of the code base. There's module generators for JavaScript and TS here. And so these are imported into sort of this root entry point of just generate, runtime, and emit. And we go through, create the module for the TypeScript types. We go in and create the module for the, there's also support for ESM. So we can output CJS, which is like the old CommonJS require, or we can also output ECMAScript modules so that those can be for imports. And supporting both gets a bit hairy, but as a user, you shouldn't have to think about it. It should just work. So we kind of put in the effort there. And so there's the JS create module. So yeah, there's a bit of noise here with regards to supporting ESM. Basically, the important part is that we create the JavaScript file and the TypeScript file. These become then emitted to your disk. So the generate steps already happened here in the create module. That gets us all the content for those files. We just then iterate over the files and output them to your disk. That's basically it. That's the part of this. So if we jump into what does the TS create module do, you can see that create module there receives the DMMF from the Prisma schema that we talked about before, And it also receives settings from the GenTime. So depending on some of your unique configurations there, we'll be able to have that when we're generating the modules. The types are concerned with, so there's sort of this long file here where we kind of basically go through the DMF and we're looking at like render TypeScript declarations for enums, render them for your models. We have things like render the Prisma node documentation to description. So all those sort of things we were looking at before, where we were accessing the dollar description and things like that. There is, of course, a runtime correspondence to that, but we do a bunch of sort of static, and this sort of lays out, this is what makes it feel static, is that we're actually going out and putting out the entire API surface statically in TypeScript types. So that's pretty straightforward. It's not that big of it. It's a few hundred. It's about just under 400 lines of code. Then for the JavaScript part, here it's a bit more dynamic, even though it is generated. What's interesting is it's so here it's like a very, you'll see how small this is. Basically, we have some imports that we do, and again, it supports ESM or CJS. We do some imports at the top. Then we access the GenTime settings. Now, to access the GenTime settings at runtime, what we do there is we stringify what you've configured at generation time, and then we kind of insert that as JSON into the source code. So that's just a little sleight of hand there, and it does limit to some degree what we can do with GenTime, because, for instance, you can't like at generate time you wouldn't be able to like pass a function, and that's why there's sort of generate time and runtime settings, and there's sort of two APIs for that, because certain things that what we can put in generate time, we will, but because there are like a function or like a custom instance of Prisma client, for example, you can't pass a custom instance from your generate time, stringify that, and get that back at runtime. So so yeah, we try to privilege the GenTime config as where sort of as much lives as possible, and then we JSON sort of stringify, insert that into the generated code. Then we just have some DMMF that we also create a variable of, and then that DMMF gets consumed by this JS create Nexus typedef configurations. And so this is sort of a more dynamic piece of logic. But you notice that the dynamic piece of logic, all we're statically doing is writing the code that calls it. But that sort of static runtime, it is actually still static runtime that creates the typedef configurations over the DMMF. So we're not doing that at generate time. And the reason we do that, and the reason we keep that code static, is mostly for implementation simplicity, so that it's still like, it's not like we have to go print strings and for all this stuff. We still just have a normal project in that regard with like a normal type checking, normal build. So we want to limit this kind of weirdness of the generated like source code to an absolute minimum, and especially for the runtime. For the TypeScript types, we're a bit more. That's what we're kind of leaning more heavily on to make this look really static. But on the JavaScript side, it's really only a couple dozen lines of code that we're generating. All right, I think I'll wrap it up soon. I just want to show a little bit what this create Nexus, what this function looks like. Oh, it's actually in the same module. So this is again static code here. And so what we do with this is we iterate sort of how we did with the TypeScript types. We take the DMMF, we take the settings, and this time we have not just the GenTime settings, but we also have the runtime settings. And from there, we're going to, so this is sort of a shallow function that calls out to other functions. We're going to use the DMMF to get all the object typedef configurations and all the enum typedef configurations. And then from there, you can see sort of what, if you recall the API, you have like the dollar name, the dollar description. You can also see here, let's see, I think the object one is interesting because that's where you have the Prisma client being called. So this is object type, field, name, resolve. Yeah, for resolve, so we jump to that. This is sort of a meteor function. You can see it's a bit bigger, and that's just doing a lot more. Well, first of all, there's also quite a few checks because the resolver depends on you putting your Prisma client instance on the GraphQL context. That's how it accesses it. And if you don't do that, well, if we didn't do any checks, it would you get some error like undefined is not a function, right? It's like a very generic and not very useful error message. So we do a bunch of runtime checks here to validate that you've configured your project properly. Currently, you can't disable these, but we will add that kind of as a production optimization where all of this will be just skipped in production. And finally, after those checks, you can see from the DMMF, we've got in what is the model for that's being used. So we access the Prisma. This is the Prisma client instance. We access the model that's being accessed. So now we have that Prisma model. Then we find unique. This is like a quick duck type. So if we don't have find unique, then yeah, this is not going to work. But otherwise, we have a lot of type safety is kind of lacking a lot in the deeper parts of the implementation because it's so dynamic. So this is like where obviously the tests are really helpful for us. Then for the find unique, we do this where unique and reject on not found. We treat that as false so that we don't want Nexus Prisma to be making that assumption. There's a comment in some sort of docs about that. And then finally, for relations, we use the chaining API, which we might switch away from in the future. But basically, once we have a result, we can just access the field name, and we call that. And this is using. I don't know if the Prisma client chaining API is so widely used, but it can be pretty convenient. It's kind of a shortcut from the implementation right now, but we might optimize that more in the future because this does make multiple round-trip calls to the database. And there's cases where for certain kind of relations, like we wouldn't need to. We can do that in one call to the database. But yeah, so some of the more gnarly part of the implementation is in this resolver function. A lot of the other stuff I would say is actually quite straightforward, and it's mostly a design problem space of like, how do you make Nexus Prisma a nice API to consume? But on a technical level, I think it's actually pretty accessible and pretty easy to work on. Okay, I think that's it for my talk.
Thanks, Jason. That was really insightful. And I mean, like, this was the first time for me diving really deep into how Nexus Prisma works under the hood. I mean, I've used Nexus Prisma quite a lot, and I really enjoy it. And I think there's a couple of things that I think would be maybe good for our viewers to emphasize here. And I'd love to sort of hear your perspective on it. So one of the things you sort of went into detail into was the difference between gen time and runtime. And as far as my understanding goes, gen time is what's happening when you're running a development server that essentially looks at your Prisma schema, well, the generated types from the Prisma generator, Nexus Prisma that is, and then it essentially gives you all of that type safety while you're actually writing your GraphQL code. So that means if you basically if you add a new field to your Prisma schema, the dev server of Nexus will basically pick up, oh, there's a new type that has been generated, and it will also give you immediately feedback on that. Whereas runtime really is a lot of the concerns that come from actually the code that you're generating, like a relation resolver that is automatically. Is this a good way to understand this?
I think so. I think that there's even like ways like so for example, there's one early feature we added was you can choose to how do you want so in Prisma schema you can have IDs on all models will have IDs, but you can choose those to be strings or ints. And then in GraphQL, there's this aspect where there's actually a type for IDs called ID, and it's designed to be sort of slightly different from a string. And so I think we have a pretty easy case there to say, well, we're going to take Prisma IDs that are strings and just going to make those GraphQL ID types. But then for Prisma IDs that are ints, should those be ints in GraphQL, or should those be IDs? And we default to IDs, I believe, but we didn't feel like that call was obvious enough to warrant it to be, like, we basically said, okay, this needs to be configurable. Now, when it came to where do we make this configurable, in the runtime or the generation time, because it could work in either, we decided to push it to the generate time, and just to sort of make it, because it has sort of like, there's like a lower kind of constraints on Gentime, like or rather Gentime has higher constraints, right? It can do less. So by kind of giving it, like, it has the least power, but it sort of allows the runtime to be more sort of specialized. So the Gentime will be basically necessarily more declarative, for example, and everything there has to be serializable, and everything there has to sort of encode sort of some kind of DSL. The runtime should probably be more minimized, and I think the classic use case is that you want to pass a custom instance of Prisma client instead of using the one that's off the GraphQL context. In that case, we really can't help you with the Gentime config, but where we can, we try to push the complexity sort of down the stack and say, use the Gentime config. But it's a bit ambiguous. There is definitely like a large gray zone there where it could work in either. There's also some things that only work in Gentime. So one example is JSDoc. When you want to customize the JSDoc, so we, for instance, ship, I think, like examples. We have some pretty rich JSDoc. We also ship like JSDoc where if you didn't put a comment in your Prisma schema, we'll give a default JSDoc that says, hey, you should like maybe consider putting a comment in your Prisma schema and like make this more useful. But some people might kind of intentionally not be doing that and like don't need that warning. And you wouldn't be able to at runtime configure and disable the JSDoc. You actually have to do that at Gentime. So there's basically a sort of a Venn diagram here. There's a lot in the middle, and there's some things that only runtime do and some things that only Gentime can do. And right now, the bias has been to sort of, in that gray zone, we try to push towards the Gentime. Yeah. Does that answer?
And if we were, yeah, totally. Thank you for explaining that. And if we were to just take a step back, before we get into, we have some questions from the audience. If we were to take a step back, I think it's worth also clarifying this. When would someone want to use Nexus Prisma?
So I think it's great for, so first of all, you probably need to know Prisma and know Nexus a bit. I don't think it's necessarily a great tool to learn those. I think just getting experienced with what is it like to use Prisma, like vanilla Prisma? What is it like to use vanilla Nexus? I think those are great experiences to just start out with. Also, using Prisma and Nexus works great. And you'll end up, even if you are using Nexus Prisma, you're going to end up using Prisma directly with Nexus a lot anyways. So Nexus Prisma, where it kind of comes in handy is once you kind of know the lay of the land a little bit and you feel like you're ready for a bit more abstraction, and you recognize that your API layer is reflecting, of course, something in your database layer, then you can just start rolling out kind of incrementally fields, relations that you feel can just be streamlined. I think you don't necessarily, like, you shouldn't feel pressured to or be led down a path which is like replicate your database schema in your API, because that will be very likely not what you end up wanting to do. But I think, yeah, it's a good tool to either for prototyping, then just kind of do whatever and just go as fast as you can. But then in a production case, it can just be kind of a little time saver, and it's much more declarative, right? So like you kind of condense like 20 lines of code down to 1, and your whole team can kind of just rally around that convention. It does make things a little bit easier to parse. So, yeah.
Right. Thanks for sharing. So we had Eric asked, can you write a delete mutation? I'm having problems with it. I think this is going to be a bit of a hard one to tackle in this live stream.
Right.
But maybe we can, I can find an example and maybe share that in the chat. And we also had another question from, I hope I'm pronouncing the name correct, Sake Codes. He wrote, very cool, Jason. Thanks for sharing. Is this ready for use in production? Will it keep supporting the latest features in Prisma as Prisma updates? And so you mentioned this in your talk, right? That we are using Nexus Prisma.
Yeah, we use it, which is a great, like, we still consider the library itself to be early access, so to speak. And so for people that, we do that for the community to sort of do due diligence, right? It's not 1.0 yet and stuff, but in our production code for the Prisma data platform, we use it. I think it's, it's something to evaluate. In terms of like the direction, it's definitely going to stay a Prisma generator. the API is still evolving, but it's not like going to radically explode and become something else. And what's also, I think, sort of reassuring about trying that library out early is that a lot of it is static. So in the sense of like the types and things. So in a setup, if you're using Nexus Prisma, if you upgrade to a new version or something and there's a couple of breaking changes, like you're going to know about it at build time, basically. So I think it's a fairly safe library to try out, and it doesn't do too much. So I think it's not like you're going into an experimental framework, right? This is really almost there are of course those resolvers, but a lot of it is just data. So it's a fairly safe library, even small library to use. But if you want to like wait for the official 1.0, yeah, then it's not quite there yet, and that might be this year, but it's not like a super high active project that we do at Prisma. It's something kind of a little bit more on the side. So it's hard to say when exactly that certified 1.0 will happen. But, yeah.
Thanks for sharing. Anything else you want to share before we wrap up, Jason?
No, I there's one sort of stealth project I'm working on the side that I would love to talk about, but I can't yet. At least at like in large scale. But I will say that it revolves around TypeScript and documentation, and I will probably be talking a lot more about it later this year. So you can follow me on Twitter if you're curious about that. And otherwise, thanks for everyone's time.
Jason, thank you so much for joining. It was really great having you and super insightful talk. So thanks for sharing your insights, and we look forward to having you here again.
All right, me too. All right.
Ciao.
Ciao.
Okay, moving on. I've got a couple of announcements to make, and then we're going to move on to our last talk for today from the very great Jamie Barton. So to our announcements, we have a Prisma Meetup Remix edition. So we'd like to invite you to join us for this special edition of the Prisma Meetup, where we'll be talking about all things Remix. And Remix, in case you haven't heard of it, which I guess most of you have since you're here at a GraphQL Meetup, is a full stack web framework that has taken both the tech world by the storm. And in this meetup, we'll take a deep dive into the features and see how it fits into the Prisma ecosystem. And we'll have 3 great speakers, including Austin Grimm and 2 other speakers. So this is going to be live streamed on February the 15th at 8 p.m. Central European time. And if you join the meetup, you also have a chance to win a ticket to Node Congress, which brings me to Node Congress. So Node Congress, a fantastic 2-day conference, is taking place on February the 17th and 18th. And it's a 2-day conference, as I mentioned, on Node.js, Edge native workers like Cloudflare, Fastly, serverless, Dino, and all the JavaScript backend runtimes. And the conference will be gathering backend and full stack engineers from across the globe. And I believe that Prisma's developer advocate, Alex Rohini, will also be giving a talk. So be sure to join us. And now I'm excited to invite Jamie Barton for our last talk of today. In case you're not familiar, Jamie is a software engineer who turned into a developer advocate. He was born and bred in Northeast England, and he loves learning and teaching others through video and written tutorials. He also maintains a headless drop shipping starter, a headless commerce resources, and also GraphQL WTF. So with that, I'm now really excited to bring Jamie to the stage. How's it going, Jamie?
Hey, great to be here. Thanks very much. Great intro.
Yeah, well, I mean, you made it easy. And today you're going to be talking about federating the content layer. And you're going to be talking about GraphCMS, right, where you're working.
That's correct, yeah. Looking forward to it.
All right, cool. So I'll give you the stage, and we can also do a Q&A if you have time after the talk.
Yeah, that's excellent. Great.
All right.
Great. So thanks very much for having me today. Today, I'll be talking about federating the content layer with a tool called GraphCMS. I'll talk about what that is and what federating the content layer means throughout this talk. But just before this call, I was on a call discussing the state of GraphQL. And actually, federation is something that comes up more often than not on any call you're talking with anyone around GraphQL. I've got all these different services. How do I get them to mix them together? And this problem is only getting bigger. So my talk is actually very well fitting to that trend as well. So hopefully by the end of this, you're kind of intrigued on how you can federate your stuff through a headless CMS, and it's kind of you might think it's a bit unordinary, but with GraphQL, it fits right in. So GraphCMS is a headless CMS. It was probably the first GraphQL CMS, if I remember correctly. And it's something which I've used for many years. It's GraphQL native. It gives you, as a content editor, some powerful tools to edit that content. When you sign in, you create your models, you design your schema, you relate things, you use asset fields, and so much more. And what we will do inside of GraphCMS is give you a content editing experience using custom fields. If you specify a Boolean, we'll show you a toggle. If you specify multi-line text, we'll show you a text area. Rich text will give you some kind of powerful rich text tools as well. So pretty much what you'd expect from a headless CMS. However, when I was talking about federation, which is what we're going to talk about today, this is this idea of bringing multiple services together. And if you're working with content, if you're building something with the CMS and you're accessing that data over GraphQL, well, don't you, what if you have data in other areas that don't belong in the CMS, but some of that content relates? Well, we can kind of give you the tools to do all of that. So that is this idea of content federation at GraphCMS. So like anything else, it is worth talking about the past to in some way justify the future, right? So, way back when, websites and the CMS world, building websites, we were stuck with FileZilla and Macromedia suite of tools to build websites, and it was an amazing time. Can we call it that? It was a great time to be alive, right? Don't get me wrong. We had all these powerful tools. We could upload files to the web and edit content, but it was just a bit like we had this website and a CMS, right? How did it start? Well, the traditional CMS, if we think back when, was mostly websites. You had a website. It was more or less a theme that you could, tweak colors, upload background images, change, turn some knobs and levers, and it would give you kind of some customized output. And it was very tightly coupled to a specific framework, whether it be a programming framework or something like the LAMP stack. It was pretty much tightly coupled to kind of what was shown to the user, to what user developer could do. Everything, was just kind of, it was, like I say, it was a fun time doing all of this, but it wasn't a great experience. And more often than not, if you were building websites for clients or you were a business, you kind of just had to buy in and you get everything. Whether you wanted it or not, you paid for everything. And often with these, it was slow, right? Like it was really slow to fetch content. Like you had to wait for the page to go make trips to the database and bring that back. It got really slow. And there was back then it was just things were server rendered and, or you uploaded static files, and building those was a bit, it wasn't as good as it is today. And I talk about often, it was often slow and server rendered because I'll come on to this in a little while on improvements we've made there. But yeah, the traditional CMS was okay, but it was often a bottleneck for going beyond. So some of the traditional CMSs, WordPress, Adobe Experience, Joomla, Drupal, and so many more were like what we used. They were the what we'd refer to today as the monolith, right? These are the monolith, and you get what you're given. But content delivery, well, this is what it looked like. You made a request, it would fetch the HTML. That HTML would kind of be generated from different files you have by talking to the database. That response would come back and build all these things and give it to you. And that took time. Everything from this point took time. You made a request, you're instantly waiting for something, which was was the best experience. It was slow, and this inspired the approaches we see today with static site generators, creating better caching and edge computing. Like that's improved massively. So the present, okay, we have this headless CMS, and content's evolved. It's outgrown just the internet. Content is now delivered on mobile applications, website. I think my fridge has a display on, and that content is updated from somewhere else. Anywhere you see something is probably managed in some kind of content management system or experience manager to kind of deliver that omni-channel content, the content as you were. So yeah, if you're a developer, you kind of get all of these different tools. You outgrown the PHP LAMP stack thing. PHP is still cool, don't get me wrong, but we have so many different tools today that give you as a developer so many different kind of options. And working with the headless API, you can do that. Headless API doesn't care where the content goes. It's its thing that gives you a content editor, content editing experience. And as a developer, the API is to output content to any kind of tool or framework that you're familiar with. You haven't got to reskill, relearn everything. You can just move on. This is stuff we're familiar with. This is the current day of being a developer. It's really, it's moved on a lot from the past. And the headless CMS today, well, mostly it's front-end agnostic. Some come with pre-built starter kits, reference applications that you can use to kind of get going. But most most CMSs will just give you an API to get going with and build what you want. Most of it is kind of CRUD. Like if they expose any APIs, you'll be lucky if you can create, update, and delete something in that CMS through the API. Most of them will give you kind of read access. But over the last few years, we've seen a huge explosion in the amount of CMSs, headless CMSs that have came around, and these are offering these advanced kind of CRUD functionalities. And yeah, as I was going, as I said about the past being tightly coupled, well, with a headless CMS today, that's fairly decoupled, right? Like you can implement what you want, where you want, and just get the data from, a CMS. And that would be one kind of data source. And you as a developer have tons of flexibility. You can, like I said, you can use whatever framework, whatever tools you're used to. You haven't got to relearn anything. You can just use what you want. But like I said earlier, some of these headless CMSs are limiting in getting going. Like it takes quite a bit of time to design your schema, create your content, or import it if you have something else. If it's not a greenfield project, you've got to bring your content, you've got to model it, you've got to figure out the best design for the data and whatever. And then you've got to worry about building a front end. And most of the CMSs kind of come with limited starters or reference applications that have not been maintained for forever. So sort of a meh landscape, you could say. And most of these headless CMSs today have APIs and SDKs, which is fantastic. Which is fantastic, and you can integrate with your Git pipeline and have content coming through on preview, deployment, URLs, and everything we're used to today with these atomic deploys. We can incorporate data from a headless CMS. But often with that rise of the destinations has also been a huge increase of the different data sources over the years. So the last few years alone, we've seen people, certainly due to the pandemic, we've seen people now kind of moving towards e-commerce. More e-commerce use cases than ever have kind of risen throughout that. And that's fantastic. We now have all of these different tools and services to support those businesses. But we've got this bit in the middle. We've got our content, we've got our PIM, which is containing all of our inventory. Maybe we have some kind of e-commerce payment platform, checkout or whatever. But then we've got this bit in the middle, which you kind of have to build. It's because the middleware, it's expensive because you've got to maintain it, you've got to develop it, you've got to hire people to kind of connect the dots here. And there often is quite a bit of disconnect between the systems as well. This because the middleware is mainly just kind of massaging data from multiple sources into one response to go to your different destinations. But what if there's something interactive on the destination? That's got to go through the middleware. Then it's got to go, oh, okay, I'm going to the CMS or I'm going to the e-commerce API, whatever. There's this bit in the middle which is just painful, and it takes time to develop and scale. We've seen a huge rise in the different kind of tools as well. So you're not just kind of confined to this little import box inside of WordPress way back when, or Joomla, where you had the ability to kind of build these plugins, but you had a little window. There was no source control. There was no kind of atomic deploys to preview those. And we've seen a huge rise now today in the different platforms that have done this. So PipeDream's a favorite of mine that kind of just allows you to have that code editing experience inside of the browser that gives you an endpoint to run some code, and that can act as my custom middleware. People can now log in, they can change that, they can they can use the PipeDream UI to connect different services. It's a lot easier, and it's it takes less skilling to build these different kind of connections. If someone places an order and I want to send them an SMS with something like PipeDream or a serverless function, I can hook that up fairly quickly. As opposed to way back when, or even non kind of headless CMSs. But yeah, these are relatively painless to kind of create, but they can be kind of painful to manage in larger teams, or kind of just get started with this. And we've seen tools like StackBlitz that give you immediate access to something that you can get going and show with your team. We've seen amazing stuff with GitHub and what they're doing around the code spaces, allowing people to just kind of collaborate together. So there's fantastic efforts to kind of make this kind of developer experience a lot better, and in larger teams, and working with these kind of different connected services. So it's really cool. But let's go back to content delivery. This talk is about content federation and content in a CMS. This is traditionally what we may be used to today with a static site generator, where we have this thing that the client requests, and they get a response, and they get some HTML, CSS, JavaScript, put on the page. If you're lucky, you just get the CSS, JavaScript, and HTML for that page. It doesn't bring the whole thing. And the static site generator, at the build time, when you deploy this goes off to the different data connection sources, gets the content, gets any templates it needs. And this is kind of federation in a way with data at build time, which is really cool. So yeah, this is kind of the modern, this is an approach today to use SSGs to build these static pages. But often the SSG can be slow, right? We've seen CMSs over the years kind of evolve to be the fastest, the greatest way to build static sites. And we see, these static site generators, keep evolving and re-releasing and improving and kind of doubling down on their efforts to kind of improve the build time, because that's kind of a bottleneck for most people. If you've got a large website, it takes time to build that. If you've got tons of different data sources, it takes time to kind of aggregate the responses from all of those and build an output. So yeah, this does take time. And obviously, as your data increases in complexity, this is just a very small. I picked this from a tool called GraphQL Voyager, I believe, from an old project that doesn't have too much going on. This is, I think, a blog that has comments that people can register and leave, and comments can be approved or be in a moderation queue. There's very little going on, but that is what the data looks like for that project. But you can imagine if you bring in sources from external systems, or you kind of graduate beyond just a blog, this is going to grow in complexity as you bring in e-commerce and your payment, everything else. So as data sources grow, so does the build time. So what do we do beyond this point? What do we do with this SSG? Do we stick with that? It's the same, it's the same problem as what we had before, but just it's a different solution. You could think of it. So, and often this isn't a great experience if you're deploying something and it takes time to build. Your content teams want to see that immediate feedback. This is something which comes up more often than not when I speak to clients and customers. They create content and then they're having to wait for build times. And this goes back to what I was talking about with these kind of limited starters. If a kind of API, a CMS provider is building something that isn't, using the latest tools and techniques to kind of get around some of this, it can be kind of quite a jarred experience. I certainly have loved using Next.js with their preview mode that allows content editors to kind of switch into this content mode that it kind of serves on demand the content from these different sources, which is really, really cool. So there are kind of solutions today that kind of help us get around that. But you've kind of got to do a lot of that kind of wiring up yourself. So yeah. But what I want to talk on for the rest of the talk today, and kind of give you a little bit of a demo on how we're doing things differently, is we would like to replace in some way that build process with GraphCMS taking care of the data access. We want to kind of federate your different content sources and where data comes from. And we want to kind of go and get that. We then want to kind of give you the tools to cache that, and we'll keep that and return that to you. If that data is then it needs to be invalidated, then we can take care of that as well. And the next time your users request that data, we'll send you along a new fresh version and we'll cache that. And we want to give our customers one API. As a developer, having to kind of mix between all of the different SDKs, I've worked on projects that have maybe used 3 or 4 different dependencies, and there's tons of different DSLs to learn. There's a lot of specific language about all of the different tools that I'm using, and I'm having to learn and relearn and rescale and keep an eye of change logs that are happening. And it's an experience. It's great. We've got the flexibility. We broke up the monolith into all of these different microservices, but today we want to begin to think, how can we kind of bring those back feeling like a monolith, but still giving you the control and the flexibility you need. Remove that need of managing multiple SDKs and APIs, and give you one API that's GraphQL, and it works with all of the tooling in that realm to fetch data, fetch content, fetch templates, and everything else. So let's go to the future. Well, actually, we're kind of there right now. Like I was talking about, removing this SSG need, the necessity to use a static site generator. I seen the Prisma Meetup talking about Remix. That is something which is, it's in connection with the return of server-side rendering. Remix gives us the power to, control some of that cache that we want to show, but also it's kind of serving that stuff on demand. And, the reason why it's doing that is because tools like Cloudflare, Netlify, Fastly, edge computing is now a thing. Everything moved to the edge. We've seen with Vercel's recent announcement with Next, they are moving more things to the edge, so things can get back to the user faster, and that computation is taken care of at the edge. So server rendering, it's cool again. It's cool. It is. And that's why Remix is really cool as well. And it's worth checking out and worth attending the Prisma Meetup as well, because that's doing some things in this area to kind of show you, look, there is more in the ecosystem for people working with JavaScript to get content from whatever data source that it is, and kind of move all of this together. So I'm running a little bit short on time, so I don't want to take much more of your time today, but I kind of want to jump into a bit of a demo. But I kind of want to think just very quickly beyond headless, what it looks like for us at GraphCMS. So people have got these different needs, GraphQL, having different content services, and whether it be backend, front-end agnostic, and whether I provide content services, we think we're uniquely positioned because we don't really care about the front end, and we kind of provide you the headless content services, but we don't care about the back end. We will soon, there's users using this right now with our remote fields API, and it's only going to get better very, very soon. And that means we're backend agnostic. You could use GraphCMS, but not use any of our kind of data at all. You could just say, here's my schema, here's the endpoint, and we'll handle that request for you, and we'll cache that. So we don't really care about you using our editing experiences. But what you can then do is you can bring that content into your project. Your content editors can then enhance that data. If I'm bringing hotels, say I have a list of hotels stored inside of my GraphCMS project, I could have reviews on TripAdvisor that I'm fetching through that federated API layer with remote fields. And then my team could then enhance those by relating featured reviews or things I want to show on the homepage, and kind of connecting to those other services from different platforms. That is what we do kind of differently. We allow you to kind of connect on the front end and in our content suite to different kind of backend services as well. And we really don't care where that data comes from, REST, GraphQL, or anything else. So this is pretty much where we sit today. We have this available to anyone that's interested to learn about not having to build a GraphQL server, not having to kind of figure out how I connect all these different services together, and just use a UI that allows you to kind of plug and play. We do that, where we are now, this is using a concept called remote fields and UI extensions that allow you to enhance the UI with your own fields and experience for content editors. So if you want to give users their own kind of custom rich text input or text area input or drop down, you can use UI extensions to override all of that in the system. So you can just kind of be away with what we give you by default, and you can bring in everything of your own, which is great. Like, at that point, we're kind of content editing agnostic as well. So there's tons of different stuff you can do. It's amazing. And we do this, obviously, of course, with GraphQL, because we're GraphQL native. That's where we started. That's where we are. We love GraphQL. I do have a video to show, just kind of walking through this. I didn't want to kind of risk the demo gods and something go wrong. So I recorded a quick video. So Daniel, I will need to just kind of change to a different slide, if that's okay.
Sure thing. Yeah, let's do that.
Hopefully this is the right one.
All right, let's bring it up.
Awesome. So I can't zoom in. I do apologize. But this is the GraphCMS interface. And what I'm doing here is creating a model, and I'm just calling this remote model for the purposes of this demo. But this is if you've ever used GraphCMS before, you could create models like you would a GraphQL type. We'll generate the GraphQL type for you. You can then add a field. Here I'm creating a single line text field called username, and then I'm connecting a remote source. We're making this is kind of in beta right now, which will be available very, very soon. But we're giving you, as kind of someone that's managing your project, to go and configure where your remote sources live. This example here is a REST source. Right now, we're kind of pasting in what the types look like. We'll introspect and do stuff in the future to make that easier for you. But right now, you give it a type for your REST API, for the GitHub API. But let's say we want to connect a GraphQL API. Here we'll insert the SpaceX endpoint, and we'll give it the introspection URL. This will then go ahead and introspect that and return what it needs for the API, which is really cool. So now we've gone back to the model. We're now going to connect that REST field that we're going to create a new field. That's going to be a kind of a REST data source. And then we're going to specify the remote source that we created, the remote source connector, and then kind of connect the user from GitHub into this GraphCMS project, if that makes sense. And we'll do the same for the GraphQL field. We'll kind of add the field for SpaceX capsules. We'll then say what part of that API we want to do, what query we want to do, and then any variables that we kind of want to pass along. I'm not passing any in here, but we give you that kind of flexibility. Then, if I switch to the content editing side of GraphCMS, you'll notice here I've got no data for my remote model. But if I now insert a username and click test in this example, that's then going to GitHub and getting everything in there that has testing for the repositories there, and then all of the users, sorry, and then the SpaceX capsules as well. And all of this data is available through GraphQL. It's not just something that content editors have access to. I created a field that I inserted a value in, and now that value is talking to multiple data sources with that same value to fetch you the content through the GraphQL API that we provide. Now, this right now is all query-based. We do have a mutations API as well for kind of managing, publishing, scheduling, updating, deleting content, and doing those in batches. We'll kind of hopefully extend to the kind of the federation part here as well. So you can then begin to make changes in different services through that one endpoint. So if this has been interesting and you kind of want to learn more about content federation and kind of want to have a play around with this, feel free to kind of just reach out, join GraphCMS, ping me in Intercom or in the Slack community, and I'll get you invited to a project so you can test this out today. But yeah, that's my demo for today.
Thank you, Jamie. That was really insightful. I mean, it was a good throwback also to developing websites in the early 2000s when the LAMP stack was still a thing.
Yeah.
It seems like we've come full circle, doesn't it?
Yes, it does. I was just saying this on the State of the GraphQL talk is we spent so long kind of separating the monolith and breaking it up into different services that now managing those is got a little bit tricky. Management is asking, can you release this feature? And it's not just as easy as checking a box or installing a plugin. We've got to wire up all of these different services. So federation and this idea of federating services and APIs is only increasing in demand.
I see. And we have a bunch of questions from the audience, so I'll go through them. So someone asked, could a CMS be, I think he meant accessed from an API? The API could act like a utils folder just for all sorts of clients.
Yeah, that's possible. Depending on the CMS that you use, you could, if it's a headless CMS, it's going to give you some kind of API. And yeah, you can just kind of create a client. If you're using if it's a GraphQL based and you have some kind of code generation, you can generate a lot of that code ahead of time and then just invoke that where you need it. And that can call to kind of multiple clients.
And generally, Jamie, do you recommend using, like, for consumers of GraphCMS, do you recommend using the GraphQL code gen in order to get all of that type safety for on the client or on the consumer side?
Yeah, absolutely. We often see people who will just get started creating something, and then when you kind of want to kind of make sure everything's kind of type safe, a lot of people do look to use GraphQL code generator. That has obviously tons of different configuration options that allow you to kind of tweak it to your needs. And if you're using something like Urkel or any other kind of GraphQL client, then you can generate all of that stuff ahead of time. And then all you need to do as a developer is import something from an automatically generated file. And yeah, it saves so much time. It's really cool.
You get all of, like, not just the type safety, you get the auto completion, right? And you get the switch kind of experience.
Yeah. And like variables as well. Like if you're passing some variables to a GraphQL query, in GraphQL, that's, it's type safe. And if you're using something like Graphical or GraphQL Playground, it tells you what those should be. You get that same experience in your IDE when writing these queries or invoking the functions to run those queries is, oh, this requires a username. It's of type string. Yep, I must provide it. Like, it's, you're going to get those errors during the, kind of when you're writing the code there.
Yeah, very nifty. Yeah, so Sake Codes asked this. He said, "This is awesome. Where can we try this?"
Yeah, so if you head on over to graphcms.com and sign up for a project, you can create a GraphQL. You can create a project. You can create some fields in your schema, and you get a GraphQL API automatically, and it's free for certain, there's a limit on content entries and models and stuff. If you want to get started with the federation side, we have an SDK currently that allows you to manage this stuff that I've just kind of went through. You can add remote fields for REST endpoints, and the GraphQL support, and should be in beta within the next few weeks. So if you're interested about getting, if you kind of want to try this out in the UI, like I showed in the video, just send me a message in Slack or on the website, Intercom or whatever. Just say that I sent you, of course, and they'll kind of tag me in that. And yeah, we can get you invited to this as soon as it's in kind of beta for everyone. And you can begin to try it, but love your feedback on how it is now and where we can take it.
All right, thanks, Jamie. And we had one final question. Can you make a good tutorial on full stack TypeScript? You may actually have one, don't you?
I don't have a TypeScript course. I am working right now with a friend of mine on a full stack tutorial, e-commerce tutorial using Prisma, GraphQL, and GraphQL code generator, TypeScript, and all that fun stuff. So that's coming. Once we find a designer to help us with the landing page, that tutorial will come. But we've been using Prisma, and it's been absolutely fantastic. To do that, full type safety and stuff like that is awesome.
Great. So Jeremy, stay tuned, and you can also follow Jamie on Twitter, and I'm sure you'll announce it there. So that brings us to the end. Jamie, thank you once again for sharing your time and your insights and knowledge and experience. It's been really great having you, and I believe that folks can find you online on Twitter. You are also, recently I've seen you doing a lot of live streams. Is this part of the GraphQL WTF?
Yeah, so people can find me on Twitter. I'm notrab, which is Barton backwards. And also you can go to graphql.wtf. You just realized what my username was, didn't you?
Yeah, it took me a while.
Yeah. Yeah, so people can find me on Twitter, or they can go to graphql.wtf, and I do a new video on GraphQL every Monday.
Great. So check it out, graphql.wtf. And with that, I'll say goodbye and wish you a good night, Jamie.
Thank you very much.
Okay, we are about to come to a closing, but before we have the raffle, and we have a winner, and the winner, and I hope I pronounce this correctly, is Jose Riquelme. So Jose Riquelme, we reached out to you by email, and yeah, I hope that you enjoy this book, Building Micro Front Ends, and I believe this is the end of our meetup. Yes, it is. So thank you so much for joining today. We are about 1 hour, 50 minutes in, so I won't take any more of your time. Just wanted to thank you once again for joining us today, and stay tuned. You can join the meetup group to get updates, and we also share them on Twitter. So if you haven't subscribed already, subscribe on YouTube, Twitter, wherever you may find us. And with that, I wish you a good night or a good morning if you're joining from a different time zone. Ciao.